On screen we see a sample IP address, specifically an IP version 4 address, and before we can really start effectively working with IP addresses and doing things like subnetting and designing and asking how many hosts can belong to a subnet and so forth, we need to understand binary numbering and how to represent an IP address in its binary equivalent. And that's going to be really important later on, so let's think about that. When we think about the IP version 4 address specifically, we use dotted decimal notation where we take the IP address and we separate these 4 separate numbers with a period, or a dot, like 10.1, .2, .3. And each of these numbers, separated by a dot, has a binary equivalent, and that binary equivalent can be represented with no more than 8 bits. For example, we see the binary bits that make up a 10, 00, 00, 10, 10. We'll be talking about how to make that calculation, but I want you to notice that we've got 8 binary bits for each of these dotted decimal positions. And since we have 8 bits, each of these numbers in our IP version 4 address, they're called an octet. An octet is 8 binary bits. And what we want to do in this video is learn how to make this calculation. How do we convert from decimal, a base 10 numbering system, to binary, a base 2 numbering system, and vice versa? To start off with, we want to construct a binary conversion table. We're going to make a table. You can do this on paper or in an exam environment. You're given the dry erase marker typically and a laminated piece of paper. You can draw this table out on that laminated piece of paper if you want to do your calculations during the exam. And you're going to have 8 columns in this table. Starting from the right, we have a 1 and a 2. Notice they double each time. 1 doubled is 2, and that doubled is 4, and that doubled is 8, and then 16, 32, 64, 128. Why these numbers? Because we're using a base 2 numbering system. These are the powers of 2. Starting at the right, 2 raised to the power of 0, pretty much any number raised to the power of 0 is a 1. 2 raised to the power of 1 is a 2. 2 raised to the power of 2, in other words 2 squared, 2 times 2, that's 4. 2 cubed, 2 raised to the power of 3, 2 times 2 times 2, in other words, that's an 8. 2 to the 4th is 16, and so on and so on. And once we get our table in place with these column headings, we could take an 8-bit binary number like we see here and very easily convert it into its decimal equivalent. Notice that under some of the columns we have a 1, under some of the columns we have a 0. So if we were asked to come up with the decimal equivalent of this number, this is all we do. We look under the columns that have a 1, and we just add up the column headings. There's a 128 that has a 1, so we say 128 plus, what's the next column that has a 1? It's a 16. 128 plus 16 plus the 4 column has a 1, the 2 column has a 1. We just add up all the column headings that have a 1 in their column. 128 plus 16 plus 4 plus 2, that gives us a decimal equivalent of 150 for the binary number of 100-10110. It's a little bit more complicated when we go in the other direction, when we're given a decimal number and we're asked to calculate the binary equivalent, but it's very doable. Here's the question that we ask. We start at the left-hand side of our columns, and we ask the question, is 167 equal to or greater than 128, our leftmost column? Yes, it is. If the answer to this question is yes, then we're going to place a 1 in that 128 column, and then we're going to subtract 128 from 167, and that's going to give us a remainder of 39. Then we move over to the next column and go through the same set of questions. We ask, is 39 equal to or greater than 64? No, it's not. In this case, because it's not greater than or equal to 64, we put a 0 in the 64 column. We're still working with the number 39, and we move over to the 32 column and we ask, is 39 equal to or greater than 32? Yes, it is, so we're going to put a 1 in the 32 column, and we find the difference. We subtract 32 from 39, that's a 7. We move over to the 16 column and ask, is 7 equal to or greater than 16? No, it's not. And because it's not, what do we put there? We place a 0 in the 16 column, and we move over to the 8 column. Under the 8 column, we're asking, is 7 equal to or greater than 8? No, it's not greater than or equal to 8, so we put a 0 in the 8 column, and we move over to the 4 column. Is 7 greater than or equal to 4? Yes, it is. That means we're going to put a 1 in the 4 column, and we're going to find the difference. We're going to subtract 4 from 7, and when we do that, we get a remainder of 3. And we move to the 2 column. Is a 3 greater than or equal to 2? Yes, it is. As a result, we're going to put a 1 in the 2 column, and we're going to find the difference. We're going to subtract 2 from 3, and that's going to be a 1. We're in our final column. Is 1 equal to or greater than a 1? Sure, it's equal to 1. Yes, it is. We'll put a 1 in the 1 column. Is there any difference? No, there's no difference. 1 from 1 is 0. By the way, it just happened to work out in this example that we didn't get a remainder of 0 until we were in the final column, the rightmost column. Sometimes, though, your remainder might be a 0 and you're only on column 8 or column 32. If that happens, that means the rest of the columns are all zeros. For example, if you were trying to convert 128 into binary, you would put a 1 in the 128 column, and the remainder would be 0, so that would mean that all of your other columns would have zeros underneath. Now that we've gone through a couple of examples together, I want to challenge you. You might want to pause the video, and I want you to calculate the decimal equivalent of this binary number that we have on the screen. 011 010 11. Again, you might want to pause the video and resume after you've done the calculation. What is the decimal equivalent of this number? All right, let's reveal the answer. This is a very simple calculation. We simply add up all of the column headings that have a 1 underneath. In our case, we're going to be adding up 64 plus 32 plus 8 plus 2 plus 1. That's going to give us 107 as our decimal equivalent. Let's try going in the opposite direction. Given a number, a decimal number of 49, my challenge to you is this: calculate the corresponding binary number. This is going to take a little bit longer probably. Again, please pause the video and come back after you've done this decimal to binary conversion. Let's work through the answer together. We're going to ask that series of questions that we did earlier. We're going to ask, is 49 greater than or equal to 128? No, it's not, so we're going to put a 0 in the 128 column. Let's move to the next column. Is 49 greater than or equal to 64? No, so we're going to put a 0 in that column as well. What about 32? Is 49 greater than or equal to 32? Yes, it is. Let's put a 1 in the 32 column. Let's find the difference. What's the remainder? If we subtract a 32 from 49, that's going to give us a remainder of 17. We then move to the 16 column and ask, is 17 greater than or equal to 16? Yes, it is. That means we're going to put a 1 in the 16 column, calculate the remainder. 17 minus 16 is a 1. We now ask, is 1 greater than or equal to 8? No, we're going to put a 0 in the 8 column. We're going to move to the 4 column, ask the same question, and 1 is not greater than or equal to 4. We're going to put a 0 in that column. Same thing with 2. 1 is not greater than or equal to 2. We're going to put a 0 in the 2 column. Finally, in our rightmost column, is a 1 greater than or equal to a 1? Yes, it's equal to 1. That means we're going to put a 1 in the 1 column, and our difference is 0. You may want to do some practice on your own. I encourage you to do that. We've been through a few examples together, but you can use a calculator application. Most operating systems are going to have some sort of a calculator application built in, or you can probably download one or find one online. In this example, I'm using the calculator from Microsoft Windows 8, and it's about the same as what you would find in Microsoft Windows 7. And if we want to do binary to decimal conversions, we go into the View menu and we select the Programmer option. Notice that we've got DEC for decimal, we've got BIN for binary. Let's say that we wanted to convert, let's just make up a number like 73. Let's convert 73 in decimal. We want to convert that to binary. We're going to click the bin radio button, and we're going to get the binary equivalent. Something to notice here, we only have 7 digits represented on screen in this calculator. If you do this calculation on paper, you might come up with 8 digits. You would have a 01 001 001. What you need to understand is the calculator result it's not going to show leading zeros. Since we're dealing with 8-bit octets, we're going to see those leading zeros. That's going to be significant to us because we're going to be working with IP addresses. But if you're looking at the result in this calculator, there's no need to show a leading zero. It's like when you write the number 12. You don't write 0012. You just write 1, 2. Same thing here with the calculator. We're not going to see those leading zeros. Just remember, when we do our calculations, when we're working with IP version 4 specifically, we're going to have 8 binary numbers that make up an octet. So on paper, again, this would look like 01001001001. If we wanted to go in the other direction, let me clear this off. Earlier, we went through an example where we calculated the decimal equivalent of 100101110. You might recall that example. And I enter that under binary. If I want to get the decimal equivalent, just to check my work, I click on the decimal radio button, and just like we calculated manually earlier, we've got a decimal equivalent of 150.